Greetings, everybody. Welcome to today's webinar presented by PIMSoft. We thank you for joining us and hope you find this webinar informative and valuable. Today, we want to demonstrate Sigmafine's approach to support refinery oil losses, identification, analysis, and control. This webinar will discuss how Sigmafine leveraging data reconciliation and improving the management of material movements will have a positive impact on the accuracy of loss accounting. Today you will learn the best way to identify losses, how Sigmafine can play a key role in a loss reduction program, and the best practices for improving measurements and reducing uncertainty. There are a few housekeeping items to keep in mind during the webinar. This presentation should last approximately 30 minutes, followed by 10 minutes of Q&A. If you have a question, submit it using the chat window on the right-hand side of the screen at any time during the presentation. We will answer all of them at the end. The presentation will be made available afterwards for you to download. We will send you an email with a link to the presentation as well as a link to the recording of this webinar. At the conclusion of this presentation, please give us your feedback so that we can make this experience and subsequent webinars even more valuable. Thank you for your attention. Now it is my great pleasure to introduce our presenter for today, Marco Lantieri, PIMSoft's Industry Principal for Refining and Petrochemicals Industries. Marco?
Hydrocarbon loss accounting is quite an evergreen topic. Losses have a significant impact on the environment due to undesirable emissions, on the safety of people operating the plant, as leaks can cause not only exposure to noxious materials, but also they can be the cause of accidents. And last but not least, on the profitability of a production process. Regarding last point, it has been estimated that a loss reduction program can bring savings in the range of $2 to $10 million per year for an average size refinery. Moreover, thefts are one of the most obvious forms of leaks, are heavily affecting the oil and gas industry. Very famous is the case of Shell Singapore refinery, where thefts have involved several levels in the company and several years to reach an amount of estimated in around $150 million. Moreover, Ernst & Young estimated that worldwide in 2021, around $133 billion worth crude and refining products are stolen or adulterated every year, which is quite an impressive figure. So today we have identified already some important reasons why we should care about refinery losses. But now let's understand better what do we mean by loss. In this presentation, we will use the approach and the definition given by the Energy Institute and more specifically by the HM31 guidelines. If we analyze a facility, on one side, we have the inputs, which we can describe as processed inputs, such as receipts and imports of materials, and inventory changes in the feedstocks. On the other side, we have the process outputs, so the dispatches, consumptions, so fuels that are used as internal consumption of the refinery, and finally, the inventory change in the products. The difference between the two sides represents the total losses of the refinery, and later we will analyze them in more detail. In this bar, there is a qualitative representation of the performance of the refinery evaluated based on the level of losses, of total losses. Don't take this figure as written on the stone, it's just for indication purposes. However, the Salomon Index suggests 0.5% in the threshold to define which are the better performing refineries. Losses, of course, fluctuates over time. So a statistical analysis on the losses is important when doing a loss control program. In this case, the trend in green represents the aggregation of 3 years of historical data based on monthly losses, which is the baseline of the distribution of the refinery losses. In orange, we provided the corresponding statistical distribution. So if the expectation is to reduce the losses by an amount which is half the current standard deviation, this will be translated into a benefit of around $1.5 million for considering 100,000 barrel per day refinery and a price of $75 per barrel. Again, this is the benefit you might achieve by applying data reconciliation only without taking into account changes in instrumentation. So let's see how this is possible. The procedure starts taking into consideration the total measured losses, which can be divided into accountable and unaccountable. By accountable, we mean losses that are either measured, for example, flares, or that can be estimated, like, for example, using some correlation to estimate the evaporation of tanks. The unaccountable instead represent what is not measured is the random error, bias, leaks. So altogether, what the part that you cannot account for. The role of Sigmafine is to reduce the inconsistencies between the input and the outputs. At the same time, it also reduces the uncertainty of the data. Therefore, it can have a double action, both on the accountable and on the unaccountable losses. So finally, the total loss reduction turns into the economical benefit. Let's see a practical example. So a typical loss report, you see it on the left, based on the measured data, so before the reconciliation, and then the same report is presented based on reconciled data. So we see that in this case, the reconciliation was able to improve the agreement between the inputs and the outputs. By doing so, the reconciliation reduced the level of inaccuracy in the data, spread the random error, and therefore it had a positive impact in reducing the total losses and more specifically the unaccounted losses. The accounted losses in this case were already quite well measured. Even just reducing the unaccountable losses, the reduction we got is around 0.4%, which for this type of refinery, considering the throughput and also always considering the oil price at $75 per barrel, turned into an economical benefit of $1 million per year. Furthermore, Sigmafine decreases the overall loss uncertainty. So not only the loss value as a whole, but also the uncertainty associated. And here we reported the formula indicated also in the guidelines of the Energy Institute to calculate the total uncertainty and how to aggregate the real uncertainty of each component of the losses and come to the final figure. So also in this case, the associated loss uncertainty has been reduced. So the numbers we are looking at are more reliable compared to the raw data. If you want to start a loss reduction program, these are the suggested steps to be implemented, considering that this is an iterative process for a continuous improvement. So you don't do it once for all, but you need to make it become a practice in your facility. First of all, you need to do an analysis of the current status of the plant losses. So you need to take into account the history of your data, and typically not less than 1 year. By looking at this data, you will create a baseline. So you will understand what is the current level of the losses in your facility. And from the baseline, you will make up a potential target and then create a set of actions to be taken. Actions that are twofold. So on one side, on the balance, and we have seen how the introduction of Sigmafine can improve the values. On the other side, on the instrumentation. And also here we will see how Sigmafine can suggest how to improve the instrumentation to furtherly reduce the level of losses in your plant. After running the balance for a few months, the results need to be assessed and actions to be taken on that basis. After 1 year, a new baseline can be reasonably created and compared to the previous baseline to evaluate the overall benefit. So what does this mean in terms of Sigmafine modeling? So moving from production accounting to loss accounting requires also a shift in focus. In terms of time range, typically we move from daily to monthly cases. So the total amount of the measured value can be fed aggregating the reconciled data of the daily cases, and also the tolerance can be set as the average of the reconciled tolerances of the months. Also, for the stocks, we can take a similar approach. So for the stocks, we need the opening and closing on one side on the daily production day. On the other case, so for the loss accounting, you need the monthly closing and opening. The tank tolerance is typically 0 for the production accounting because in many cases, tank quantities are considered fiscal quantities. For loss accounting, this is not always true or is not mandatory anymore. So you could consider this either 0 or consider it as part of your loss or gain effect, and so put it as a percentage of the stock change. Finally, for loss accounting, you need to feed more information to the model. So you may want also to include estimations and so increase the level of accountable losses and reduce the level of the unaccountable. So you want to include flares. You may want to include correlations for tank briefing and tank evaporation. And finally, of course, you need to represent the unaccounted losses. And to do so, you can do it by creating, for example, a meter which is measured at 0 with a tolerance set as a percentage of the throughput. Now let's analyze in more detail how some of the Sigmafine functionalities can improve the balance and help reducing the losses. So one of the biggest sources of gross errors, which heavily impact also the losses or mask part of the losses, are the misdeclarations of movements. On one side, there is the Sigmafine diagnostic that helps identifying major imbalances around nodes and inventories, and it can detect areas where possibly a movement declaration was missing. For a more comprehensive approach, we suggest instead implemented a dedicated application for the movement management, such as the Sigmafine Intelligent Movement Management, which is fully integrated with the Sigmafine models. So the movements that are declared with IMM are readily available also for the balance. Another source of gross error is related to the conversion from volume to mass basis, especially in the crude area. One issue is related to the density, which might not be adequate enough. On this side, the composition and quality tracking algorithm can take care of the different blends of crudes. So if you monitor type of crudes, you have some measurements, and plus the quality tracking, you can have a more detailed estimation day by day or even hour by hour of how the density is changing. The second error is related also to the overestimation of the amount of crude due to the presence of water, for example, or sediment, which are all mixed together before they are separated in the desalter. On that side, Sigmafine has built-in corrections to take care of the information regarding the amount of water and base sediment, so to automatically correct the amount of hydrocarbons, which are the ones to be used to feed the mass balance. Similar actions can be taken also on the compensation of measurements, especially for orifice plates to correct with pressure, temperature, even compressibility factors in case of gas. And for the fuel and the flow rate of the fuels, sometimes there is an online gas chromatographer available, so you can use it to get the molecular weight and then use this figure to compensate the flow rate. In other cases, again, you can just put some estimate, but it's always suggested to put a compensation in place. Last but not least, software like Sigmafine supports internal and external auditing by providing data quality KPIs associated to the balance and by recording all the data changes performed by the users. So this will help decreasing the rate of human error, which can be either unintentional, but also intentional in case of the thefts that, of which we talked at the beginning of this presentation. We also briefly talk about measurement devices because although the presentation is mainly focused on the data reconciliation impact in a loss reduction program, we cannot overlook the effect of measurement devices, which on the long run accounts for a major part of the benefit when the performance baseline is poor. So here is a brief summary of the best practices in different areas. So, for example, for crude, Coriolis flow meters provide direct mass measurement, and sometimes they also give you the associated density. These are two critical parameters, as the crude flow rate is one determining the flow rate and the performance of a refinery. So having the associated density also will provide better information on the overall feedstock information. So we work on the inputs. For flares, and to improve the measurement in flares, which typically have very different flow rates. So typically they have a small flow, but when there is some upset in the plant, the flow rate increases sensitively. So orifice plates, for example, are not working very good in these cases. Ultrasonic flow meters are suggested. On the fuel gas side, we mentioned a bit already this. We suggest also having an online gas chromatographer, because not only takes care of getting a proper composition correction, but also verifies the billing from an external provider. So typically you are purchasing gas from a supplier, but you want to cross-check if the heat content, which is intimately linked to the composition of the gas, is the ones that is expected and that we are paying for. And finally, coke is another quite complex measurement to be done, and it also affects the balance and can account for some losses due to, for example, the coke formation of by the FCC, for example. In these cases, by thinking about coke drums, the best technologies available to measure the quantities of coke stored are either radar or multi-point radiometric level measurements. Finally, fugitive emissions. This is an entire class of emission that typically involves the tank farms and many times are underestimated. Recent studies confirm that. Some of the technologies currently used to measure them are based on infrared cameras, DIAL, and radial plumb mapping. These are a few of the technologies that can be involved in measuring emissions. There are correlations in the literature, but again, also these correlations are found to be quite under predicting the amount of emissions. Now let's introduce a few use cases. First one is Petrobras. Here, Petrobras is showing the level of losses before and after using Sigmafine for their loss reduction program in one of their refineries. They were able to reduce losses from 1% to 0.5%, which is really a significant amount. Some of the improvements they did was the inclusion of a FCC coke production in the mass balance, previously was not included, and also incorporate and compensate the presence of free water in the crude receipts, which was overestimating the amount of inputs from the feedstocks. So for Petrobras, the main benefits of Sigmafine and the use in both mass and loss accounting were the identification of errors in the transactions, the correction of densities. So we talked before of these being some of the major source of gross errors, increase the precision of the conversion from volume to mass, having a unified financial and engineering departments, better visibility in the reporting and management of the oil losses, and finally, improving the return on their investment. The second case is YPF, which was presented by Emerson in last year. This relates a case study in this Argentinian refinery. A full study was conducted to improve significantly the level of the balance and through also an improvement in the instrumentation. So some of the best-in-class measurement devices were installed to improve the level, the accuracy of the measurements. And these were, you can monitor the data quality of your measurements by cross-checking measured and reconciled data. And when you implement Sigmafine, a set of indicators are available to track this data quality that supports your measurement selection. In this specific case, the baseline was very poor, showing an initial imbalance of 7.5%. Measurements compensation greatly improved the balance, and so led to a 4% reduction. And an additional 3% reduction was achieved by installing new meters. So finally, the resulting imbalance was in the range of 0.5%. So today we learned that Sigmafine can unlock much more value on top of the mass balance. The company can benefit by the use of Sigmafine for improving the oil loss reduction program. And the better loss identification means focused action to reduce emissions, improve safety, and profitability. Thank you.
Thank you for that presentation, Marco. Before we get started, I want to let everybody know if you have a question, just add it to the right-hand side of your screen, and we will try to get to those as quickly as we can. First question for you. Can you add Sigmafine to a loss accounting project that has already begun?
Yes, of course you can. As we said, at the beginning of a loss accounting project, typically the first step is doing and computing a baseline. The baseline looks back in the past. As we said before, typically 1 year of data is suggested in order to have a solid ground. Also because during a year, typically there are some shutdown of the plants. So you have to make sure that your average baseline takes into account the normal operating conditions and also these periods of downtime. So once you have this baseline, if you then put in place Sigmafine and you run Sigmafine for at least a few months, I would suggest, you have a way to compare your original baseline with reconciled figures. So this already gives you an idea of how much you could improve in your data. I mentioned also in the presentation of the reduction of the uncertainty associated to the reconciliation approach. So it means that also the initial figure that you get in the baseline can have a significant uncertainty associated with. By putting in place Sigmafine, you will detect inconsistencies with much higher accuracy. This will lead for sure to some actions even in the daily balancing. For example, you will detect if there is some movement that is missing, and you will see it because Sigmafine will highlight discrepancies, imbalances in some specific points, so you know where to look at. And in chain, you will get a better value at the end of the month in terms of losses. So for sure, you will see and you can track the benefit you get over time.
Okay. Next question. How can we make an assessment of the current state of the plant through Sigmafine?
Okay, so when you run Sigmafine, okay, let's say that for loss accounting, so typically you are in a you will get data from your daily balances, you will aggregate them, but still giving more freedom compared to a mass balancing, a standard mass balancing for production accounting. You will, after the reconciliation process, you will get some information like the overall imbalance. So you will get a feeling of the level of inconsistency. This is done through Sigmafine by when it provides indicators. It was mentioned in one of the last slides. They are called the axes in Sigmafine terminology. So the amount of, for example, of non-redundant meters, the percentage of imbalance, the discrepancy between measured and reconciled data. So all of this is giving you metrics to assess how your plant data are behaving. So, for example, if we take just for example, the DX1, it may tell you that your discrepancy level is of some percentage. If it's too high, it means that for sure you have big issues in your balance. So you're missing data sources, you're missing transfers, or even the model is incorrect. So you may have done a model which is not reflecting the reality. But you have this kind of lights that guides then your next steps.
Okay. We don't currently have any other questions, so if you have any questions, please submit them right away. We'll try to hang on for a minute or two just to make sure we get any other questions that need to come in. In the meantime, I want to thank Marco for your time preparing this presentation and to remind everybody that we will be sending out a copy of this recording along with the download to the PDF of the presentation later today.
Anyway, whoever is can also reach me later. I mean, in the presentation, there are my contact references. So in case you may want to ask something more detailed, or you can always reach me out.
Okay. Looks like we don't have any current questions coming in, but as Marco said, you can reach out to him. His contact information will be provided along with the PDF and the recordings. We'd like to thank you for your time and thank you for joining us. And I think we're going to go ahead and end the broadcast now. Thank you.
Thanks, everybody. Bye.
Bye.